Hello everyone, welcome back to the channel. Today we're going to be discussing vectors that are used in physics. Ever wondered how pilots know where to go when the wind pushes them off course? Or how hikers figure out their paths using maps? It's all about vector addition. In this video, I'll break down how to mathematically add vectors step by step so you can solve any vector problem with confidence. So first of all, what is a vector? We can say that a vector is a quantity that has both magnitude and direction. And we will use an arrow to represent this. Okay, so I'm going to draw an axis here. Usually the direction is measured from the x-axis. So this direction here is usually measured from the x-axis, and we normally go counterclockwise when we're reading this as positive. Okay, if I go the other direction, then it'll be a negative angle. The length of this arrow will represent the magnitude, the quantity. Let's start with a very simple example. Suppose I have a vector here and another one that's perpendicular to it here. Let's say that this is my x-axis, this is my y-axis. My resultant will be the vector that goes from the origin to the top of the last vector drawn. We will call that the resultant here. And this will be angle theta. So to find the resultant, I'm just going to abbreviate it with an R. So resultant will be equal to the square root of x squared plus y squared. Okay, we're using the Pythagorean theorem here. All right, the angle theta will be the arctan y over x. Okay, so those are the two formulas we'll use exclusively throughout this section. In this problem, we'll let x equal 12. We'll let y equal 9. We can say meters, be fine. So r then will be equal to the square root of 12 squared plus 9 squared, which is the square root of 225. So r is going to equal 15 meters. Okay, that's half our answer. All right, so the resultant length is going to be, or magnitude is going to be 15. So it's going to equal 15. All right, the angle theta is going to be the arctan y over x. So the y is 9, x is 12. So theta will be 36.9 degrees. Okay, what do I do about one which is not at right angles? Let's try one like that. I have this one, and I have another one taking off, something like this. My result will be here. Suppose that this first one has a magnitude of, let's say, 25, and it's just going along the x-axis. The second vector here, suppose it has a magnitude of 15 and an angle of 30 degrees. Remember, we measure everything from the positive x. We need to solve for the resultant here. This is not as easy as the other ones. If you have graph paper, you can graph this and come up with a fairly close answer using the head to tail method. But I prefer to calculate these using an XY table. So I'm going to make an XY table. The first vector is moving along the X, so it changes by 25 units on the X-axis, but it's not changing any on the Y-axis. Okay, this second vector, I would suggest doing a right triangle with an X and a Y. I know that the X portion of this will be 15 times the cosine of 30 degrees. And I know the Y will be 15 times the sine of 30 degrees. So all we have to do is just take the sum of the X's and the Y's and put them together. By calculating this, I'll say 25 plus 15 times the cosine of 30, and I get 37.99. I'm going to round that off to 38. The sum of all the X's, the sum of all the Y's will be 15 times the sine of 30, which is 1/2 that, which is 7.5. So that's my sum of my X's and my Y's. All right, to find R, then I can use Pythagorean theorem. So R is equal to the square root of the sum of all the X's squared plus the sum of all the Y's squared. So that's going to equal the square root of 38 squared plus 7.5 squared. That will give me 38.7 meters. So I know this is going to be 38.7 meters here. All right, now let's solve for the angle. All right, so I'm going to say that theta is equal to the inverse tan, the y sum over the x sum. So I'm going to get 11.2 degrees north of east. So theta here is going to equal 11.2 degrees. Okay, here's a practical example of using vectors. You have an airplane which is traveling 425 kilometers per hour in a direction 30 degrees north of east. The wind is blowing northward at 56 kilometers per hour. So what's the resultant velocity and direction of the airplane? So the first thing let's do is let's just draw as an axis. Okay. Let's draw vectors. So I'm going 425 at 30 degrees. And I have another one going at straight north at 56. Now I could draw it like this, or I could draw it like this, where I have this one and I have this one. Oops. Okay, you see what I'm trying to do. Either way is acceptable, but we'll keep it like the original here. So trying to overcomplicate things too much. We're going 425 kilometers per hour. The angle is 30 degrees. This one is 56, and it's going due north. The first vector is going to be 425 times the cosine of 30, and 425 times the sine of 30. The second vector has no x, and it has 56 for the change in y. This will be 368.1, and this one will be 268.5. So R is going to be 368.1 squared plus 268.5 squared. So R is going to be 455.6 kilometers per hour. Now let's solve for our angle theta here. Okay, this angle here. So theta is equal to the arctan 268.5 over 368.1. So theta is going to equal 36.1 degrees north of east. In the next example, a golfer is on the green putting. He strikes the ball 3 times. The first one rolls 5 meters due east. The second one then travels 2.1 meters at an angle of 20 degrees north of east. And the third putt is 0.5 meters due north. So let's see if we can get this drawn here. So that's 5. The second one is going to be 2.1 at 20 degrees. And the third one is going to be 0.5. So let's label these. This is 5. This is 20 degrees. 2.1. And this is 0.5. So my result will be here. Let's do our XY table next. All right, so the first vector is traveling along the x-axis, 5, 0, y. The second vector is 2.1 times the cosine of 20 degrees. 2.1 times the sine of 20 degrees. The third one is going straight north, so it has 0x and 0.5 y. So let's add those together. We get 6.97 and 1.22. So the result is going to be the square root of 6.97 squared plus 1.22 squared. So my result is going to be 7.08 meters. And the angle is going to be the inverse tan of 1.22 divided by 6.97. So it's going to be 9.93 degrees north of east. So this angle here is 9.93. In this example, we have a football player. Football player runs a pass pattern given by three vectors, A, B, and C. A is, he's going to be running 5 meters northward. B, he's going to be running 15 meters eastward. And C, he's going to be running 18 meters, 35 degrees south of east. Find the magnitude and direction of the resultant vector. Okay, let's see if we can draw this. So he's going to run first 5 meters to the north. Then he's going to go 15 meters eastward. Then he's going to go 18 meters, 35 degrees south of east. So it's going to be something like this. All right, so the resultant will be here. Okay, so this is 5. This is 15. North, this was east. All right, this one, I'm going to extend here, and this is 35 degrees here. So this is my resultant. All right, let's do an XY table again. In the first vector, he's changing 0 amount on the X. He's changing 5 on the Y. On the second vector, he's changing 15 along the X and 0 along the Y. The third vector, that one was 18. So he's going to be going 18 times the cosine. This gets a little tricky now. I can put negative 35 degrees, or I can say 18 times the cosine, 325 degrees. They'll both give you the same answer. I'm going to stick with the negative because I'm moving in a negative direction. So this will be 18 times the sine of negative 35. Okay, so the sum here will be 29.74 and negative 5.32. It's negative because it's below the axis here. So if this was the x-axis, it's below the axis. So therefore, it's a negative number. Let's solve for our resultant. The resultant is going to equal the square root of 29.74 squared plus minus 5.32 squared. So the result is going to be 29.26 meters. And the angle, the arctan of negative 5.32 over 29.74. That gives me negative 10.1 degrees. That tells me it's below the axis or 10.1 degrees south of east. Okay, if you like a challenging problem, here's one. It has two unknowns in it. I have a route followed by a hiker consisting of 3 displacement vectors. The first vector is 1,550 meters in a direction 25 degrees north of east. The second vector is 41 degrees east of south. And the third vector has a direction of 35 degrees north of west. The hiker ends back where she started from. Therefore, the sum of all the vectors is equal to 0. Find the magnitude of the second and third vectors. Okay, so we will try to draw this. Okay, so the first vector is 1550. 25 degrees. The next one is 41 degrees. And then the last one is back like that. All right, so let's label this. This is 1550. It's going to be 25 degrees here. All right, the next one, I'm going to draw an axis here at the intersection. Okay, the second vector is 41 degrees east of south. That makes this angle here 41 degrees. Okay, that'd be east of south. I'm going to call this vector B. Vector C here is going to be 35 degrees north of west. So again, I'm going to draw a little axis. So this angle is 35 degrees. Kind of hard to read that, but it's 35 degrees right there. Okay. So let's do an XY table again. So I have for the first vector 1550 times the cosine of 25 and 1550 times the sine of 25. On the next one I have B times the cosine of 311 and B times the sine of 311. C times the sine of 145. Since I'm having to measure all these from the positive x-axis, that's why I have to come all the way around to get some of these angles here. Okay, so let's go ahead. This is going to be done quite a bit differently. 1550 times cosine of 25 is equal to 1404.78 plus just the x's first. All right, the second line, that'll be 0.656 times B. All right, and the C portion will be minus 0.819 C's. These are the x values. The y values will be minus 0.755 B's plus 0.574 C's. And all these are going to equal 0. All right, so what I want to do is I'm going to rearrange these a little bit so that my constants are on one side and my variables on the other side. So I'm going to rewrite this first one as 0.656 B minus 0.819 C equals negative 1404.78 and negative 0.755 B plus 0.574 C equals negative 655.06. Okay, let's solve for C in terms of B. I'm going to have 0.574 C. I'm going to take this 755 to the other side, be a positive 0.755 B minus 655.06. So C is going to equal 0.755 B's divided by 0.574 0.574 minus 655.06, also divided by 0.574. We can say then that C is equal to 1.315 B's minus 1141.22. Let's remember that number. Let's take this first equation. I'm going to bring it right here. Now substitute this value for the C in that equation. So let me rewrite it. It'll be 0.656 B's minus 0.819 C's equals negative 1404.78. 0.5656B minus 0.819 C's, which is 1.315 B's, minus 1141.22 equals negative 1404.78. All right, this gives us 0.656 B's minus 1.077 B's plus 935.48 equals negative 1404.78. Okay, combining like terms, I have 0.421 B's equals negative 2340.26. Change the signs to positive. So I have B is equal to 5558.8 meters. Okay, so I solve for B. So let's take an equation like this equation, and then let's solve for C. So C is going to equal 1.315 times B, which is 5558.8 minus 1141.22. So C here is equal to 6168.6. Today you learned how to add vectors. Now you can tackle real-world problems with confidence. If this video helped you out, make sure to give it a like, share it with a friend, and subscribe for more quick math and calculator tips. If you've got questions or ideas for future videos, drop them in the comments below. Thanks for watching, and I'll see you in the next one. Goodbye.